In this worked example, once again, we are going to try and prove that these are similar. Okay, you've once again got the two options to prove that they are similar. You've either got that the angles are equal, or you've got that the sides are in proportion. Okay, they're the only two ways you can prove similarity. So, what information do we have? Do we have enough information to use the angles are equal? No, scratch it. So we're doing the sides are in proportion. Okay, now proportion, there's a couple of different ways you can do this. I don't mind which way you do it as long as you are comfortable with it. You can either do them as ratios or you can do them as fractions. The thing to remember is that ratios and fractions are exactly the same thing. It's just one's horizontal, the other one's vertical. Whichever one you're comfortable with, use it. Okay, I'm going to do it as ratios just because that's what they've done. If you want me to do it as fractions, just give me a holler and I'll laugh at you. But I'll do it anyway. So what we do is we have to use corresponding sides. This is the important part. Remember in the last example, it was corresponding angles are equal. In this one, we're doing sides are in proportion. And once again, it has to be corresponding sides. Okay? The way we can tell that they're corresponding is looking at the right angle. That gives us a bit of an idea as to which one is which. Okay? We'll start with the most obvious one. Which one do you reckon is the most obvious one?
5.
Give me the length. Now they say to use LM and PQ. I wouldn't necessarily start there.
The long one.
Yes, I'm going to use the hypotenuse. The reason for that is I can go, it doesn't matter which way they've rotated the triangle, I will go this one.
C5.
Yeah, it is the 5, Jake. It is the one that is opposite the right angle. It is the hypotenuse. And I know that they're going to be the same. If I take both sides that are opposite the hypotenuse, then I'm set. Does that make sense? It doesn't matter which way they rotate them. I can find the one that is opposite the right angle, and I know I'm using the hypotenuse. Cool?
Yeah.
Okay, so I'm going to do ln and PR as my first ones. Okay? So ln and PR are 5, and I'll do my ratio, and 15. So 5 to 15. Okay? Can I simplify that?
Yes.
What would it be? 1 to
3.
1 to 3.
They're all 1 to 3.
They bloody well better be, otherwise we'll screw it up. Now, if I'd done that as a fraction, I would have had 5 over 15, and that would have simplified down to 1/3.
So do you write L N P R and then like that?
Yes. So yeah, I should have written that first. They've got it there. So ln to PR equals 5 up to 15 equals 1/3, or 1/3. And honestly, you should actually do it like this. Oh, OneNote, you will be the bane of my existence. Okay, you shouldn't actually technically write 2 equals on the one line. You should only ever have 1 equal sign on the one line. I'm just limited for space because I'm writing fairly big. Okay, so that's the one I've done first. Now, it doesn't really matter which one you choose next, but you've got to make sure that you are choosing the corresponding sides. Okay? So on this one, I'd have a look and go, right, well, I'm going to go from, pick a side. It doesn't really matter, but as long as you can choose the one that is corresponding to it. That's going to sound really weird on the recording. We have to go wash our locks. Though I'm going to assume you meant your locks, as in your beautiful flowing hair. No? Just your locks that someone put inappropriate fluids, semi-viscous fluids on. Nah, semi-viscous fluids is alright. Could be anything. You could put motor oil on there. Okay, so to choose the corresponding one, at this point, if you can picture yourself, because they're not always going to look quite like this. So if you can picture yourself standing at that vertice, the one that's got the right angle in it, and go, right, well, I'm standing there looking at the hypotenuse, I'm going to choose the left-hand one. Does that make sense? The left-hand arm off the right angle. Okay? Now, in this one, it's pretty obvious which one it is. But if I had rotated the triangle round and done that, you have to be able to look at it and go, right, well, in this case, I'd be talking about this side here. Does that make sense? You have to be able to pick the corresponding side. Now, they're not always going to be easy to pick. If I did a triangle that looked like that and a triangle that looked like that, Who's to say that this side isn't the same as that one? Okay. You have to, yeah, the numbers will show you, or in this case, the angle. If I say that that's that angle, which is that one, and then that angle, then you can see that it's got to be, if I was standing at that point, it's the right-hand one. If I was standing at that point, it's the right-hand one. Does that make sense? You've got to be able to mentally rotate around and have a look at which one is the corresponding side. Cool? So, in this case, we've got those two, which are LM and PQ. So once again, LM to PQ, the ratio of equals this. 4/12, which equals, oh, I've done it in a fraction all of a sudden. Just changed my method. 4/12, which equals 1/3. Okay, then you do the last one, which in this case is those two. And I'll just move over here so I can see.
Do you really have to
MN.
do those other sides?
Sorry, buddy?
Do you really have to do those other sides as well?
All sides must be in proportion. The only way you can be guaranteed that they are is to do all
So
three.
what is the same, shouldn't it? In the right angles.
Yep.
It says in the right angles, shouldn't it?
If I draw this, okay, just imagine that's that one, so I've got a 5 centimetre hypotenuse, yeah?
Oh,
Okay? If I draw
if one of the
this,
sides is the same length, if one of those other sides is the same length today.
and that's 15, are they similar?
No, yeah.
You see what I mean? That it depends on those angles.
If one would be the same. If,
Yep.
Yeah.
Yeah, if you have, technically, if you have 2 out of 3, remember I said with a triangle, because there's only 3 angles, as long as 2 of them are the same, then the third has to be, and it's the same with the sides. If you've got 2 of them the same, then the third one has to be. So you only technically need to do 2.
Yeah.
Cool? So MN to P to QR equals 3 to 9, which equals 1 to 3. Now you're going to do a conclusion, same as we did yesterday. What's your conclusion going to be in this case?
LMN is 1/3 the size of PQR.
It is. That's exactly right. But we're not trying to find out what size it is.
They are similar.
So don't forget, use your notation. Use the abbreviations because it makes your life easier. Triangle, LMN, is similar to. Okay? That's where your three lines come in. It makes your life a lot easier. Rather than writing is similar to or anything like that, triangle LMN is similar to triangle PQR, and then give me a reason. What proof did we use? How can we say that they are similar? What did we use?
All sides will be
Brilliant. All sides. All what sort of size?
all
Starts with co and ends in corresponding.
correspond.
All corresponding sides are in proportion. And that is your proof. A lot of the times these will be like 2 or 3 mark questions, and almost inevitably one of the marks will be for that thing in brackets. Okay? It is very important that you are able to state why they are similar.
Dorothy!
No, Dorothy is not why they are similar.
I don't know.
Everyone happy with that?